So a lot of today is about vocabulary, okay? There's a graph there, and my question for you is, what do you notice about this picture? What kind of shape is it? What would you describe it as? A U, okay? Does anyone know the official name of it? Parabola. So we've been dealing with all of these quadratics that we've been doing, right? Factoring, completing the square, etc., etc. This is what the graph of one of those looks like. Okay? Now, next week we're going to start learning to actually graph these. But today I just want to introduce some important vocabulary. So, the first important word we need to know is the word vertex. So I'm going to click on the word right there. What do you think the vertex is? Where have you heard that word before? You probably heard it a ton last semester. When you were dealing with like triangles and stuff last semester, where was a vertex? It was a corner, right? It was one of the points of it. Now this doesn't have any points, but it does have a bottommost point here. Do you see that? What are the coordinates of that point? 0, 0. So when it says vertex and it says type as an ordered pair with no spaces, I'm going to type in parentheses 0, 0. Is it important to put the parentheses? Yes. Absolutely. Why? No parentheses. It's not a point. It's just two numbers. Okay? The next thing is the axis of symmetry. What is an axis of symmetry? Well, what is symmetry? Something matching from one side to another, correct? So on here, I have some symmetry. Okay? And on that symmetry, I don't think you can see what I'm doing here. Oop, cancel that. Get out of that mode. Okay. There is a line that goes up and down straight through the very middle of my vertex. You can't see it because it's not drawn in. But if I were to talk about this line right here, where does it cross through the x-axis? 0, right? It's always going to cross through at this point, the x value of my vertex. So my axis of symmetry, the way I type it in, it's always a line x equals something. Why x equals something? Well, because a vertical line is x equals some number. And then where was that line going to cross the x-axis again? 0. That's my axis of symmetry. So? Orientation, let's see what my options are. Is my orientation positive, meaning it opens up, or is it negative, meaning it opens down? It opens up, doesn't it? Okay. Shape. Now this one I have to talk a little bit about. It says parent, no change, stretch, skinny, compression, wide. This is what's called the parent function. Sometimes you'll hear me call it the mother function. Mother, parent, get it? Yeah. Helps people remember it. What this means is that every single parabola is some kind of a variation of the one you're looking at right now. Meaning that they might flip it upside down, they might stretch it and make it skinnier, they might squish it or compress it and make it fatter. This is what you compare it to. And here's how I tell if it's compressed or not, or if it's skinnier or not. The parent function always has, if you look at your vertex, if you go up 1 and over 1, you're always going to find another point. So from my vertex, if I go up 1 and over 1 either direction, I'm always going to find another point. Technically, I could go down 1 and over 1. If I have to go up 2 and over 1, I don't have something that's the same width. Okay? If I have to go up 1 and over 2, I don't have something that's the same width. But if I go up 1 and over 1, then I have something that is just like the parent function. It's no wider and no skinnier. Okay? Let's see what my next thing is. The graph of this function has minimum, maximum. What does minimum mean to you? A low, right? Minimum is a low. What's a max? A high. Does my graph have a lowest point or a highest point? A lowest point. So I'm going to say that it has a minimum. You follow? Now, I want the y value, or how low it goes on my y-axis. So on my y-axis, how low does it go? 0. Okay? Not an ordered pair. The only times I'm going to type an ordered pair is up here where it says to. And down here, x-intercepts or roots, they are ordered pairs. So the last thing I need to identify is, where is that graph crossing the x-axis? Or where is it touching the x-axis? It's only touching at 0, 0, correct? If it only touches in one place, what I want you to do is type that place in both of the blanks. So if it only touches in one place, just type that in both. So, we're just going to be looking at graphs and filling out this information. Let's go to the next question. My graph has changed. Do you see that? What is my vertex? Is my vertex still at 0, 0? Yeah. Yes. So I'm going to go ahead and type in 0, 0 in parentheses. What about my axis of symmetry? Remember, that's my vertical line. It has to be x equals something. X equals 0, because 0 is what's still going right vertically through the middle of that vertex. What about my orientation? Is it positive opening up or negative opening down? Negative opening down. What about my shape? Is it a stretch, meaning it's skinnier than the last one? Or is it a compression that it's wider? Or is it exactly the same width? Skinnier, because, let me zoom in a little bit here if I can. If I look at that graph and I start at the vertex, if I go, in this case, down 1 and over 1, do I hit a point? I have to go down 2 and over 1, don't I? Which means it's narrower. So when I go to talk about this, I have something that is narrower or skinnier. Pretty much everything's either going to be the parent function or skinnier. We're not going to do the compression this time. We'll add that later. Do I have a maximum or a minimum? Maximum. Why? Because I have a highest point. What is that highest point? 0. And what are my x-intercepts? 0, 0, and 0, 0. Pretty easy. Okay, let's look at the next one. You guys already going ahead? Probably. What's my vertex here? 0, 0. What's my axis of symmetry? It's not 0. X equals 0. If you don't give that x equals, it will be marked wrong. Orientation? Up. Shape? No change, because again, you can go up 1 over 1 and you're following the graph. It has a what? Max or min? Minimum value of, and my x-intercepts? I promise they'll change. Pretty easy. All right. Next one. I think things might change here. Okay. What is my vertex now? Negative what? 2, comma, negative 1. My vertex changed. What does that mean for my axis of symmetry? It's still x equals 2. Remember, it's always going to be the x value of your vertex. What's my orientation? Down, negative. Shape. Parent. It's not skinnier or wider. Does it have a maximum or a minimum? Of what? Negative 1 is the highest it goes. Notice that's always the y value of your vertex. So I'm going to stop there for a minute. Your x value of your vertex determines your axis of symmetry. The y value of your vertex determines your maximum or minimum value. What are my x-intercepts? Does it cross the x-axis? No. It doesn't cross it. So if it doesn't cross it, just type the word none and none. Okay? All right, 2 more. What's my vertex here? -2, 1. Again, needs parentheses. What's my axis of symmetry? X equals. If you don't put the x equals, it marks it wrong, and I will keep it that way. I'm not giving you credit if you don't put the x equals. Orientation? Up. Shape? Skinny, because up 1 over 1 doesn't get me on the graph. It's just off the graph. Does it have a max or a min? Minimum. What is that minimum value? 1. Does it cross the x-axis? No. So I have none and none. It's pretty easy, isn't it? We're just going to get really, really fluent with this language. What's my vertex here on number 6? 3, -4. Okay, what's my axis of symmetry? X equals 3. Orientation? Up. Shape? Parent function. It looks wider, but if you follow that up 1 over 1, it's still just 1 over 1. The difference is that it's kind of zoomed in on the graph a little bit. Does it have a maximum or a minimum? Minimum. What is that minimum value? X-intercepts. There's 2 of them. 1, comma what? And 5, comma 0. You must type those as ordered pairs like it says. Now, once we get to graphing, we're going to add another component to this called domain and range. Okay? But right now, all I want you to do is get fluent with this. Okay? All right. Happy studying.